developing a bike or updating a current bike category, we really kind of identify who that consumer is, what are they looking for, what are they going to be the advantages that Felt Bicycles can deliver for that consumer.
That information is communicated to the engineer and the industrial designer. And from there, the industrial designer starts creating sketches anywhere from wild to mild. It's all across the spectrum, and some things that just absolutely cannot happen, but you got to put them on paper and just talk about it, because you never know. Some of these crazy ideas really do happen eventually.
And then once we get that nailed down, we start drawing it up in CAD.
CAD is computer-aided drafting, and it's the essential tool. It is the hammer of the carpenter. It's the absolute only tool that an engineer really has to start communicating his idea and create a 3D model that's eventually going to allow everybody else to view and understand what it is we want to create.
What the computer can't let us do is figure out how those parts are going to interact with the frame in the real world. So we will always have to create a workable prototype with our 3D printer.
Using our 3D printer, we're able to create fitment models for everything that we designed in the computer. Obviously, bicycle is a moving part, and no matter how much you check in 3D and you create your clearance boxes and you understand how things travel in real life, fitment and moving parts, they'll definitely throw you for a loop and they'll surprise you. And so having a 3D printer to create a model that you can check clearances on has been invaluable to us. We're always aiming for the stiffest, the lightest, the fastest bike, and one of those tools that we need to do that is to use simulation. And so finite element analysis allows us to simulate different loads that a bicycle will see while it's being ridden, understand what the compliance might be like, truly design the best possible surfaces before we ever actually start cutting tools. Anybody can make a stiff frame, but to make a stiff and a light frame, you truly have to understand the concavity and the convexity of your surfaces. You have to understand what the geometry on your frame is really doing in order to have the stiffest and lightest.
We also need to make rideable samples, and that's where our CNC mill comes into effect, our welding and fixturing capability, so we can build frames in-house.
CNC is going to really help us create prototypes faster. It's going to speed up development of mountain bikes and smaller parts. The greatest advantage for us is not having to wait months for things to be made. It gives us just one more tool to try and create a bike that's better, develop it faster, develop it more completely.
Once everything is tuned, we'll go to the factory and start working in carbon fiber, and there's another process of tuning the ride characteristics and the weight and the stiffness with that carbon layout.
When that first prototype comes back, that's the best part. You know, you finally get to put parts on it and you start to ride it and make sure that the geo that you decided on really does function as you intended, and the stiffness numbers are really matching up on the table to your FEA, and then you start working on the next few sizes.
The testing process is highly qualitative, where we know what numbers we can achieve as far as stiffness, weight, travel, anti-squat, those things from the computer program. What we don't know is how much fun the bike is going to be to ride, how confidence-inspiring it will be, and that's what we need to discover on the trail. We also use input from several professional riders, cross-country and enduro racers, who are giving us really valuable feedback. They are able to push the bikes to limits that we are not physically capable of.
At Felt Bicycles, we've been fortunate to work with a wide variety of professional athletes, everyone from Olympic champions to world champions in triathlon, road. Each one of these riders brings their own perspective on what it takes to make this superior product. Things that go beyond personal preference or the average rider's own experiences. These professionals can really give us some insight into what it takes creating the best bicycles in the world.